Well, welcome, my wonderful mathemagicians. Today we are starting on a new unit and we're learning about scientific notation. Today my goal for you is to be able to identify correct forms of scientific notation and to understand why we need such a tool. You know how I just love working hard and wasting my time, just trying to work hard and trying hard to get it right. Nah. I hate working too hard. I like shortcuts. Guess what? Scientific notation is just a shortcut. Let me tell you why. Take a look at some of these numbers. Look at this. The population of the Earth right now is around 7.5 billion. But if you write that out, look at it. 7,500. And then a bunch more zeros. Yikes, I hate working that hard and trying to figure out these numbers. And all the rest of the numbers on here too, the distance from the Earth to the Moon. Now that's an easy one, really. 240,000. I don't mind that one too much. But you start getting into some of these numbers, they're huge. The distance from the Earth to the Sun is 93 million miles. Okay, that one's not hard to say, but did you know that was a million, that the 93 one? I mean, really? Look at the trillion down there on the bottom. The approximate number of cells in your body is around 100 trillion, depending on how you measure it. All right. Work smarter, not harder. That's my mantra. That's what we want to do, and that's what scientific notation will help us with. It's a shortcut. Those were huge numbers. Now look at these. They look like huge, but look where that decimal point is. All right, this one's not too bad. 0.0024. The diameter of a grain of sand. Really? I mean, do you have a measuring tool for that? Calipers that tiny? I don't. Maybe Mrs. Shepherd does. I don't know. The mass of a dust particle. Just one little dust particle. Look at the tininess of that. That is so tiny. A mass of electron. Who knows these things? Really? That's crazy talk right there. Right there. That's just craziness. So we want to work smarter, not harder. I don't want to have to write all the zeros and try to keep them straight with my eyes. Woo! So scientific notation is a shortcut for really big numbers and really small numbers. As you can see, this is a really big number. But look over here, 5.2 times 10 to the 24th. I can handle that because we know the exponent rules too. And if we don't remember, next lesson, we're going to review the ones we need. All right? So, really big numbers, really small numbers. But we got to have a few rules. So, here's a pretty big number. Here's a pretty small number. You know how I know that? Even though they look very similar. Like right here. Don't those numbers? Yeah. This number, even though 5.98 is bigger than 3.4, I know this is a really tiny number because, looky there. There's a negative sign in front of the exponent. That makes this a really small number, and we're going to go into more detail in the next lesson on what do we do about that. How come the minus sign makes it smaller? But I want you to remember today, the minus sign on the exponent, where'd my pointer go? Whew, there it is. The minus sign on the exponent makes it a tiny number. Doesn't make the number negative, okay? Makes it a tiny number. And a positive exponent makes it a bigger number. So here's the rules. The first number right here, we call it the digit number, we call it the digit, we call it the first factor, all different ways we call it. Where'd my pounding go? There it is. All right, that has to be between 1 and 10. And I have a little diagram down here. It actually can be 1. It can be equal to 1, but it has to be less than 10. It can't be equal to 10. So it's got to be between them. Okay, it's got to be between them. Then we have to have a multiplication sign, so like this. I see those here. Okay, we got those here. And then there has to be power of 10. So 10 raised to some number. It can be positive or negative, depending on whether we got a big number or a small number. So, how do you pick them out of a crowd? Well, here's a crowd. Let's go through them one at a time. Let's pick them out, and I'll tell you which ones are which. And I want to get a cool color. I'm sick of red. What do you think? Let's use, purple. Okay, so let's take a look at our first one here. 34.76 times 10 to the 5th. Now remember to compare it to our little thing here. It has to be equal to or greater than 1 and less than 10, our first digit, our first factor. Is this number greater than 1? Yep, it is. But is it less than 10? Oh, no, it's not. Bad choice. This is not. We don't even have to look at the rest of the number. This is not written in scientific notation, so you're going to say no. Okay, let's move on to the next one. We have 4.90 times 10 to the negative 32. 4.9, is that bigger than 1? Where's my 1? There it is. Yep, it is. Is it less than 10? Yep, it is. And is 10, well, we got our times. All of these have the times, so we know that. Good. We're all good on that. And this one's to 10, which we said has to be raised to 10 to some power. And it is 10 to some power, so this is a good one. Yay! All right, next one. 0.34, is that equal to 1 or bigger than 1? Oh, no, it's not, right? Anytime we have a 0 over here in front of the decimal point, can't be. Can't be. Nope, nope, nope. That's a bad one. All right? Don't even have to go any further. Okay, next one, 1.5. Yeah, bigger than 1, right? Smaller than 10? Good. Now keep going. We got our times. Oh, wait a minute. Mrs. Horn snuck in an extra 0. Can't do that. This is not scientific notation. Even though it really looks like it, don't fall for my tricks. Okay? Just saying. Don't fall for them. That is not scientific notation. Okay. Next column, let's take a look. 9.564832. That's a big number. Is it bigger than 1? Yep, we got a 9 here. Is it less than 10? Yep, we got a 9 here. Doesn't matter how many digits are out here. It's still less than 10. So that's so far so good. Times 10 to the, whoa, what's that exponent? 698? Who put that in there? That's nutso. That's a huge number. But yeah, everything's good. This is a good scientific notation number. Very good form. All right, next. 10.01 times 10 to the negative 3. Well, it's greater than 1, but wait a minute. 10.01. It's just a teeny bit too big. Doesn't that count? Nope, it doesn't. Nope, nope, nope. Can't count it. Nope, nope, no. All right, that is not scientific notation. Let's look at our last one. Let's see if we got it. 8.9. Is that greater than 1? Of course. Less than 10? Yeah. All right, times 10. Base 10. Yep, we're good there. Negative 5,852. Wow. Whew. I hope Mrs. Shepherd knows how to use these kinds of numbers in her science class. But, oh, man, that's crazy. This is a good number, though. There is nothing wrong with that one. It is scientific notation. All right, I hope you were listening to my carrying on and that it made some sense to you. If not, go back and listen to this part again, because now it's your turn. Which of these three numbers is not written in scientific notation? Don't let me trick you. Okay, number 2. Pick it out. Which one's not written in scientific notation? Number 3, another one. Which one is not written in scientific notation? Don't fall for those tricks. Number 4, yepers, one more time. What's not written in scientific notation? Alrighty, 5, I've changed the question. Finally, it's getting so boring. Which number is written in correct scientific notation form? You can do that. All right, I promise. Last question, at least on this video. Which number is written in correct scientific notation form? All righty, guys. Hopefully by now you know the difference between a big number and a small number. And you can identify the correct forms and not be fooled by any little shenanigans I might try to pull on you. And I hope you understand why it's so helpful. And oh, yes, you know me. I love my shortcuts as long as they get me to the right answer quick and easy. And scientific notation is one of those things. All right, thanks for watching. Have a great day.